Okay, 1-3 solving equations is what we're up to today. Alright, so when we solve equations, we're going to take all of our variables and try to find numbers for them. So this says an equation that contains a variable may be true for some replacements of the variable and false for others. So the number that makes the solution true is, the equation true is the solution of the equation. So something like this, 5x equals 10. We should know by now that the solution of this is 2, because if I put 2 in for x, that makes both sides equal to each other. Alright, so a solution of the equation is a number that makes an equation true. Alright, so let's look at some properties of equality. Reflexive. Reflexive is like a mirror. You look in the mirror, you see the exact same thing. A equals A. Symmetric. So this is the same as, pause for a second, what property that we've talked about is this like? If you said commutative, nice job. Commutative and symmetric, same thing here. Transitive, if A equals B and B equals C, then A equals C. This is very, very useful, the transitive property, okay? So this is kind of like a string from one to the next. A to B, B to C, which means I can jump straight from A to C. That's transitive. All right, addition property. If I add the same thing to both sides of an equation, that's allowed. Same thing with subtracting and multiplying and dividing. Okay, I'm allowed to do that. The one thing that the caveat here is division. Can't divide by 0. We can never, ever, ever have 0 in the denominator. Can't divide by 0. And last one, substitution. If A equals B, you can use B wherever you see A. All right, so substitute it in. Anytime you see A, you could use B if you wanted to. All right, so let's go ahead and solve this one. 13y plus 48 is equal to 8y minus 47. All right, so what I'm going to do on this one is try to get all the variables on one side and all the constants on the other side. So I'm going to compare the two variables. I'm going to pick the smaller one and get rid of it. So I'm going to subtract 8y to both sides. And I've got 5y plus 48 equals negative 47. All right, so now I've got all the variables over on one side. So now I need to get all the constants to the other side. So to do that, I'm going to cancel out addition with subtraction. Minus, oops, not 47, 48. So that these can cancel out. If I do it to the left, I need to do it on the right. And so 5y equals, they're both negative, so we're going to add them together. And this would be negative 95. One last thing, I want to have y all by itself, so I need to get rid of this 5 somehow. And since this is 5 times y, I'm going to divide by 5. And we'll end up with y all by itself equal to negative 19. I did that in my head. What I was thinking is 100 divided by 5 is 20. Okay, I knew that. That was one piece I knew. So 95 is one set of 5 smaller. So that's going to be 19. So y is negative 19. All right, you're up. Try the understanding check. All right, here we go. Problem 2, let's distribute on this one. So we're going to distribute first, and then we're going to do the moves we did on the last problem. So distributing comes first. So let's distribute. 7 times 2 is negative 14. And remember, this is a negative 7. So when I times it by another negative, I get positive. 70 plus 21 is 91. What I did in my head there to multiply that, 7 times 10, and then 7 times 3 is the same thing as 7 times 13. Okay, 7 times 10 is 70, 7 times 3 is 21, so you can put them together and get 91. All right, let's look at the right side. 3 times negative 2 is negative 6x, and 3 times 9 is 27. So we've distributed first. I'm going to simplify both sides if I can. All right. The right side over here is very simple. combined all our like terms. X's are with x's and regular numbers with regular numbers. But over here, I can put the x's together. So let's go ahead and do that. 3 minus 14 is negative 11x plus 91 equals negative 6x plus 27. And so let's figure out which one is smaller of the x's. Negative 11 is smaller than negative 6. So we're going to add that one. Try to cancel out the smaller one. This will cancel out. We'll have 91 equal to 5x plus 27. And now we need to get our x's by themselves, so let's cancel out the 27. And we'll have 5x equal to, those cancel out, and 91 minus 27 is 71, minus 7 more is 64. And so our final step here is to divide by 5. And so we're going to have 64 over 5. You can't reduce that. Equal to x. Okay? All right, you're up. Try the understanding check. Okay, so next one here. We have equations sometimes that have more than one kind of variable in them. We can have a formula here with a and h and b1 and b2. That's 4 different variables here. All right? We can solve for any of those that we want. So when it says solve for, that means get by itself. Right? Get by itself is what solving for is really saying here. So in this equation, right now we've solved for a. Right? A is by itself. But it says, well, what if we wanted to solve for h instead? So we want to rearrange this so that we have the h all by itself. So a little tricky here. So let's see if we can figure this out. So this is a whole bunch of multiplying going on. It's a half times the h and h times the parentheses. Got to get rid of both of those things. All right? Well, let's start with the fraction first, because if we see a fraction, let's see if we can get rid of it. That's always going to be our rule of thumb. How can we get rid of a fraction? Remember, to get rid of a fraction, multiply by the reciprocal. Okay, 2 over 1. If we do it on the right, we're going to need to do it on the left as well. 2 over 1 is just 2. So 2a equals, those cancel out, and now we have h almost by itself. Still have the parentheses. How are we going to get rid of those parentheses? So this is almost a trick here. Don't be tricked by this plus here. We need to cancel out the whole parentheses, and the whole parentheses is multiplying the h. To get rid of multiplying, we are going to divide. Divide away the b1 plus b2. Okay, so the whole parentheses will cancel out, and look at that. We have h all by itself. 2a over b1 plus b2. And that would be your answer if you were solving for h. So now your job, try to solve for one of the other variables in your understanding check. All right, so let's look at this one. We're going to do the same thing. We're going to solve for x, but we're going to test any restrictions. So sometimes we'll get an answer, but we also have to say, okay, this is our answer except you can't use certain types of numbers. So we're going to figure out what those exceptions are. All right? So restrictions kind of mean except for, and then fill in the blank. Okay? So let's see here. We want to get x all by itself. So we have x plus over a plus 1 equals x over b. Okay? All right. So one thing that we could do here, let's see. We could get x's all on the same side. That would be helpful. So if we did this, minus the x over a, minus the x over a, we would have 1 equals x over b minus x over a. Now all the x's are on the same side. Okay? But we do need to get rid of these fractions here. Okay? So what we can do is multiply times the common denominator, which in this case would be a and b. We're going to multiply each fraction by a and b. So on the left we've got ab, these b's cancel, and we'll have ax minus bx. All right, the fractions are gone, so that makes it a little easier. We want to get x by itself, so we need to factor out the x's. All right, this term has an x, and this term has an x, so we can pull the x out in front. Okay, might have to remember this from algebra. A minus b is what's left. And now we would do what we did on the last problem with the b1 and the b2. We can divide both sides by a minus b. A minus b. Okay? Those cancel, and so our final answer here is x equals ab over a minus b. Okay? And that's our answer, except for we're going to say comma, x cannot equal a few things. Okay? So here's what we're going to say. Remember that you can't divide by, if you said 0, nice job. You can't divide by 0. So here's our restrictions. We go back to the original problem. I see denominators, and I see a in the denominator. Okay? So I'm going to say it's not x that the restriction's on, it's a. A cannot equal 0. Okay? What about another denominator? B. B can be anything you want, except it can't equal 0. That's no good. And then our last thing here, look at our final answer. So we're going to check two places. The beginning, and then our final answer as well. Our final answer here has a denominator, a minus b. A minus b cannot equal 0. All right, and another way to say that is if we added b to both sides, a cannot equal b. So there's three restrictions here. A can't equal 0, b can't equal 0, and a can't equal b. Other than that, you can pick any numbers you want for a and b. All right? So, might be a little confusing. We might have to go over this in class. If you get it, very nice. But do your best. Try the understanding check for example 4. All right, I believe this is our last example. Nope, 2 more. Here we go. Real world connection, construction. The dog kennel owner has 100 feet of fencing to enclose a rectangular dog run. He wants it to be 5 times as long as it is wide. Let's find the dimensions of this dog run. All right, so 100 feet of fencing. I like to draw diagrams. Okay, that's one strategy. We know that it has to be 5 times as long as it is wide. So if the width is x, the length has to be 5x. And we know I have 100 feet of fencing. Is that perimeter or is that going to be area? Okay, fencing needs to go around the outside. So that's going to be perimeter. So the perimeter is 100. And that equals x plus 5x. And then we need to go around again plus another x plus another 5x. Okay, so drawing the diagram really helps me do this problem. Might want to do it that way. There's some other ways to do that. Okay, so if you do this problem a different way, that's fine. But let's solve it from here. 100 equals 1 plus 5 more is 6 plus 1 more is 7 plus 5 more is 12x. So let's get x by itself and solve. So 100 over 12 equals x. We can reduce that. These are both even. So how about 50 over 6? Oh, they're both even again. How about 25 over 3? And that's as far as we go. X equals 25 over 3. Final answer. Okay? No restrictions on this when we look at our problem here. No denominators, right? So no x's in the denominator, so we're perfectly fine. Now try example 5, or understanding check 5 for me. And here we go, last one. The lengths of the sides of a triangle are in the ratio of 3, 4, 5. So I'm going to just draw a triangle here and say 3x, because I don't know what x is. 4 and 5x. Okay. The perimeter is 18. All right, this looks very similar to the last problem. We're going to add them up. 18 is 3x plus 4x plus 5x. Let's solve it. 18 is 3 plus 4 is 7, plus 5 is 12. And yet I wrote 5 for some reason. is 12x. Let's divide by 12. So 18 over 12 equals x. And we can divide both of them by 6. We get 3 over 2. So x equals 3 over 2 for our final answer. Okay, so that's x. Now, is this our final answer here? It's actually not, because we want the lengths of the sides. We got to go back in here and replace x with 3 halves. Our answer. So 3 times 3 halves is 9 halves. That's one side. 4 times 3 halves is 12 halves, which equals 6. And last one, 5 times 3 halves is 15 halves. And we could do these decimals if we want. Fractions is totally fine to leave them, but we could do this. Might be helpful to add them up this way just to make sure. 7.5 plus another half is 8, plus 6 is 14, plus 4 is 18, and that's what we should have. Okay? All right, so that will do it for today. And any questions, make sure we get them answered in class. Good luck.